Okay, just want to talk about this circuit that we were looking at in class there, and I believe, I figured out how it works, and it's a lot easier than I was thinking how it worked originally, which is in line with what I've been saying, that we make electricity and electrical diagnosis hard in our brains when it's really not. So I was doing the same thing, just making it harder than it actually is. So I did a bit of reading, a little bit of digging, because I wanted to know how it worked, and I think I've got it figured out, and I can show you on a little circuit builder. So right here we have our BCM, our left rear door module, and our left rear door latch. Same thing we're looking at in class. And how the system works, how these two work in conjunction, is the BCM sends a voltage signal down this line. And you can find this information. Here you go. BCM sends a voltage signal to each door ajar switch. So there's our door ajar switch, right? It's sending 5 volts, I'm going to pick 5 volts. I think I picked 5 volts. I did. I picked 5 volts. I'm going to pick 5 volts. It might not be 5 volts. It might be something else, but we're going to stick with 5. So it sends a signal down here, right? And this is basically a ground. This return line, it goes up to the power windows up here. And that's just a ground coming from the power windows, but that doesn't affect this circuit, which is why it's not shown right now. So this is just a ground. So it grounds in the door module, sends 5 volts, grounds in the door module. And then for the door unlock, over here, we do the same thing. The door modules right here send a voltage signal to the switch inside the latch. So this door module right here is going to send, again, I think I chose 5 volts. I don't know, it doesn't say, but it sends a signal to this switch. So when we have a change in this switch, that voltage reading is going to change up here. When we have a change in this switch, that voltage reading is going to change up here. So it created the same circuit in this little circuit builder. BCM, I called it DDM, it's not left rear door module, it's okay. And then our switch, I guess I could change the name, but it's fine. So here we have the same operation when one is closed in our door ajar switch here. When our door ajar switch is closed, the door is closed. If you look at our wiring diagram, when one is closed, the door is closed. When one is open, the door is open, right? One ajar, so that one means ajar, one ajar. And then here, where's back to our circuit? When 2 is closed, it means the door is unlocked. Same thing here. 2, right? When the switch moves over to 2, it means the door is unlocked. So we can take a look and see how the computer knows when the door is ajar and when the door is unlocked. So I've made some assumptions again in here. I've thrown a 10 ohm resistor in both of these modules because if you don't have a resistor, it's going to fry it. I'm also making the assumption that it's up here, that the resistor is up here in the module because it needs to see a change happen at this little voltmeter that's internal to the module. Same thing here. Oh, and I've changed, I made this voltage 2 volts just to make it different. But it could be 5, it doesn't matter. This one is 2 volts here, you can see. It can be 5, it doesn't really matter. I think I kept it different just to make sure we could see the difference. But anyways, how does it work? So let's say that our door is closed, right? But it's locked, okay? Right? So right now our door is closed and our door is locked. And you can see, if you didn't notice, this voltage reading changes. So watch up here, switch open, we got 5 volts, switch closed, we have 0 volts. So that's how the BCM knows that the door has been closed. It sees this voltage signal, which is after the resistor, pulled to 0 volts. Right? So it knows now this door has been closed because I'm not getting a reading anymore at this this little voltmeter. So door closed, door locked. DDM, well, door module knows that the door is locked because it sees a voltage signal at this voltmeter. If we then lock the door, right? So this is our lock, unlock, lock. If you look at our voltage, you can see it's gone to 0 volts. So now we know that the door is I'm sorry, did I say locked? Unlocked. If we unlock the door, we now know, or the DDM, the door module knows that the door has been unlocked because the voltage drops to 0. So locked, unlocked, right? So it knows it's a 0 volts. Our door is currently unlocked, and what it will do with that information, it'll send it to the BCM. The BCM will look at the wheel speed sensors. It'll make a determination when we're above 30. It'll say to the DDM, hey, you need to lock the door. So it will lock the door, and the little switch inside there will open. And then it knows, because it sees that voltage ramp back up to 2 volts, that the door locked. If it doesn't see that voltage ramp back up to 2 volts, it has to assume that something has gone wrong, and it'll probably set a fault for you. Same thing up here. If this switch, if the BCM doesn't see this voltage change when we move the switch, so let's say the switch is broken, right? We're opening and closing our door, but we don't have a change in voltage up here. The BCM will then assume that that door is always open, and it will leave the door jar light on. Think of an edge, right? The edges that failed, or I think it was Econolines that had problems with the little door jar switches, the ones you could replace, right? It would always leave the light on. Same thing here. So you can close the door physically, and the lock-unlock might work, right? Because this side of the circuit might still be okay, but the BCM is constantly seeing 5 volts, and so it doesn't know, that the door is actually closed. It can't physically see that. So that's how it works. That's how I believe it works. Again, I've taken some liberties here. I don't know. I know there has to be a resistor. If there's no resistor, obviously we're going to have problems, right? Let's do this. We've created a short, right? We need something. So you have to put in a resistor. I don't know if it's a 10 ohm. I have no idea. I'm assuming that it's some kind of resistance. It doesn't have to be 10. It could be 1, I suppose. It doesn't really matter what it is, as long as it's something, right? It needs to be something, and you have to be measuring. I'm guessing. Give me this. No. Okay. Sorry. Let me see. Let's see if it makes a difference. Yeah. Right. So you need to be measuring after the resistor, because you need to see, we talked about voltage drop a little bit today. You need to see that voltage disappear. Otherwise we don't know, right? So if you measure before the resistor and change the open close switch, you have no reading movement, right? Again, it will always assume it's open. So that has to be after, right? The little resistor in there, and we need a resistor for it to drop something. So that is how I believe the system works, that Focus RS. A lot simpler than I was thinking with the stacking voltages and all that business. Door module sends a voltage signal, BCM sends a voltage signal. It all goes to ground in the door module. In this case, with door modules, it goes to ground in the door modules, and all it's looking for is a change in voltage. And if it sees that change in voltage, it knows that the switch worked. Right? So door closed, switch closed, we see that change in voltage. Door unlocked, right? It sees that change in voltage. Door locked. Now we know we're back at 2 volts. Okay, the door is locked. We're happy, right? We got 2 volts. We know the door is closed. I see 0 volts. Everything's good with that side of the system. Hope that helps a bit. I'm on to the next video. All right, see you later.